Last class, we started looking at transformations of quadratic functions. Specifically, we were looking at vertical stretch and vertical compression and reflections across the x-axis. Today, we're going to continue looking at quadratic transformations by looking at translations. And translations just means shifting. And we're going to look at translations both vertical and horizontal. And as we're going through this, you're going to get introduced to a really interesting form of the quadratic function. It's called the vertex form. I tend to use it an awful lot, and I think you'll find it's a very useful way to look at a quadratic function. So let's just go ahead and start first with number 1 and talk about what's going on with that. So we want to graph this function compared to our parent function. The parent function, if you can remember, is y equals x squared. It's already graphed here for you. And we're going to compare this new equation and see what happens when we add this 2 to the back of our x squared. Okay, so if we look at that form I was just talking to you about, let's go back up to it. The one I said was so interesting. Right here, it's called our vertex form, and it's x minus h squared plus k. So in our first ones, we're just looking at this plus k. So let's go back and look at number 1. And all we've done, we've got x minus h squared plus k. Obviously, there's no h in here, so we just have the x squared. So we're just looking at this plus k. So our value of k is 2. And what we're going to need to do before we can do anything else is create a table so that we can graph it. So I'm going to go ahead and create a little xy table. And I'm just going to give our standard quadratic numbers so that we can make a quick graph. Okay, so go ahead and pause your video and fill in what the y values would be for each of these x values and graph it on your graph, and then start the video back up for the next discussion. Okay, so when I graphed the points, now I can look at it and see what my vertex is. So my vertex, if you can remember, is where our graph turns around and goes the other direction, the very bottom point. And my vertex on this guy is 0, 2. Just as a reminder from our introduction to quadratics a couple of classes ago, when we talked about our y-intercept, we always talked about the c, the very last number. So let's look, is our y-intercept at 2? And yes, it is. It's at 2. So that still holds true. That pattern that you learned about quadratics hasn't changed. Just something to keep in mind as we're going. So let's describe this transformation. Did we have anything changing here at the x? Do we have anything to give a vertical shrink or compression or stretch? We do not. We don't have a negative, so that's why it's still going, opening up. But what we do have is a tail, a plus 2, this k value. So all that's happened to our graph, it hasn't gotten any narrower, it hasn't stretched or compressed. All it's done is moved up. And sometimes this is a little confusing for students because they look at it and go, well, this looks narrower to me. But all that's really happened, you can tell from the x squared, it is not stretched at all. All it's done is started up 2 units higher. So our describing the transformation is it shifted up 2 units. And that's what happened in this transformation. So now let's go ahead and look at number 2. Now on number 2, again, we're going to have to make a quick table so that we can graph it. So what I want you to do is to pause your video, make a table, and graph the function, and then go ahead and turn the video back on for the explanation. Okay, so again, we can see that our k value is -1, and our vertex is at 0, -1. So this whole graph shifted down 1 unit. Did it have a vertical stretch or compression? We can look right here at the x squared, and no, it did not. So the only thing that happened is it shifted down 1 unit. Okay, so now let's explore horizontal translations. So what I want you to do is I want you to go ahead and make a table and graph number 3. And once you've made the table and graphed it, start the video back up and we'll discuss what's happening with a horizontal translation. Okay, so when I started making my table, I realized my numbers were going off the chart, so I had to move over some more to get a good graph. And my vertex on this guy is -2, 0. So what happened was it shifted to the left 2 units. Okay, go ahead and do number 4, same way, make a table and graph it. Then start the video back up for the explanation. Okay, so this time when I graphed my graph, it had shifted over 3 units to the right, and my vertex was 3, 0. So let's look at what this means in context. We're going to look at all 4 of our graphs and what happened with them. So starting up at the top 2, those were vertical transformations. So when our k value, on the very first one, our k value was 2. So when our k value was 2, our graph shifted up 2. So the positive k translated my graph up, and when my k was a -1, it translated my graph down. So what kind of conjecture can you make from that? How does the positive and negative k affect the location of my vertex? Well, when my k was 2, my vertex shifted up and it was at 0, 2. So it was the y value of my vertex. And on the other one, the -1 was also the y value of my vertex. So it makes the y value of the vertex. Now, did that affect our domain at all? Well, our domain is still all real numbers, so no, but did it affect our range? And it did. Our range no longer is greater than 0, now it is greater than 2 or greater than -1, depending on where we have shifted it to. Now let's look at our horizontal transformations. And in our horizontal transformations, we were looking at an h. So on the very first one, our h was a +2. Which way did our graph translate? It translated left. And in number 4, it was a -3. And which way did our graph translate? It translated right. So tell me, looking at this, is this what you expected to happen? Did you expect the +2 to go left and the -3 to go right? Not really. Most people do not expect it to do that. And so that's kind of the key part about the h value. It's really going the opposite direction of what you want. And so the very important part about looking at the h value, it's the one inside the parentheses, it's always going to go the opposite direction. So our h goes opposite. And I just remember it's the one inside the parentheses. It's going the opposite direction. How did it affect the location of our vertex? Well, it just shifted it over the opposite direction. Did it affect our domain at all? No. What about our range, bottom to top? Did our h value have anything to do with bottom to top? Nope. It didn't change our bottom to top either.